Welcome to the Explainer. Today we're doing something a little different. We're not digging into a research paper or a news story. No, we're going to tear apart a technical document, a piece of code actually, to try and understand a massive question. How do you simulate life? Let's get into it.
Dive into an immersive experience. Wow, that's a pretty powerful way to start, right? It sounds like it's straight out of an epic nature documentary, or maybe some incredible new VR game. You can almost picture it, soaring through canyons, spotting prey from 1,000 feet in the air. But get this, that quote? It's not from David Attenborough. It's translated from the product sheet for a Python module, which is basically a pre-packaged toolkit of code. That's right, it's for a piece of software designed to simulate the entire life cycle of an eagle. And that's what we're doing today. We're going to break down this digital blueprint to see exactly how you turn a living, breathing predator into a set of rules.
So how in the world do you even do that? How do you capture the essence of an eagle, its entire life, from the moment it hatches to the day it dies, in just lines of code? Well, this product sheet gives us the blueprint, and we're going to walk through it step by step and build our own digital eagle right here.
Okay, so before our eagle can do anything, hunt, fly, you name it, it needs some fundamental stats. The best way to think about it is like a character sheet in a video game. You have to lay down the basic, unchangeable rules of its existence first. The code starts with two of the most important ones.
First up, its lifespan. The simulation sets the eagle's absolute maximum age at 20 years. This is the clock, and our eagle is always running against it. Every single thing that happens, every event, takes place inside this 20-year window.
Second thing on the character sheet, its reproductive cycle. Our digital eagle can try to reproduce once every 3 years, so this rule sets the pace for how the species can continue inside the simulation. Okay, so we've got a lifespan and a reproductive clock. Now we need a way to track how it's doing, moment to moment.
And that's handled by this thing the code calls health status. Honestly, just think of it as a health bar with 4 simple states, from excellent all the way down to critical. And what's really fascinating is that this one little variable is the center of the entire universe for this eagle. Pretty much every other event in this simulation is designed to either push this health bar up or drag it down. All right, our character sheet is filled out. Now for the fun part. It's time to bring this thing to life. And this is where the simulation stops being a list of stats and becomes a dynamic game of survival. The code uses a bunch of functions, which are really just named sets of instructions, that act kind of like rolling the dice, deciding our eagle's fate 1 year at a time.
Every single turn in this game starts with one simple command: advance time. Boom. The code moves the clock forward 1 year. Our eagle is officially 1 year older. And with a new year comes a whole new set of challenges and opportunities.
The first and most common challenge is the hunt. An eagle's gotta eat, right? But out in the wild, and in this code, success is never a guarantee. So is our eagle gonna find food this year? Well, the outcome is decided by a function called interact_with environment. This is where that element of chance really comes in. If the roll of the dice says the hunt is a success, fantastic. The eagle's health status might get a nice boost, maybe from weak to average. But if it fails, that health bar starts to drop. And a few failed hunts in a row, that could be a disaster.
But it's not just about finding food. Every year, our eagle faces another massive test: migration. The check migration function simulates this whole dangerous journey. It can throw random curveballs at the eagle, a sudden storm, crazy winds, which, you guessed it, can also knock its health down. It's another roll of the dice. But hey, survival isn't just about one eagle, it's about the whole species. So if our eagle is healthy and that 3-year reproduction clock is up, the reproduce function gets called. If its health is good enough, new eaglets are born and the digital family line continues.
So our eagle's out there, it's hunting, it's migrating, it's reproducing, it's navigating this world of pure chance. But with every single call of that advanced time function, as its age ticks closer and closer to 20, the single most important function in the entire simulation is looming.
This is it, the survival check. And it really shows you the cold, hard logic of code. First, it checks the age. How close is it to that 20-year limit? Second, it evaluates the health. What's its current status? Finally, it combines those two things to determine the eagle's fate. An old, weak eagle has a much lower chance of passing this check. This function is the ultimate judge, jury, and executioner in our little digital world.
Okay, so we've built our digital eagle. We've watched it navigate its coded life, but that brings us to the really big question. Why?
Why do this at all? Why would somebody spend their time writing a program just to simulate an eagle's life? Well, the product sheet gives us some pretty cool real-world answers.
It turns out this kind of simulation is way more than just a curiosity. It has some seriously powerful uses. In a classroom, you could use it to actually show students how population dynamics work. For video games, this is how you create realistic animals that feel alive. Researchers could use it to model what might happen to a virtual species if the environment changes. And of course, for hobbyists, it's a way to add an amazing layer of realism to their own projects.
So at the end of the day, a simulation like this is a tool. It's a tool for helping us understand complex biological systems, for creating more immersive digital worlds, and maybe even for making predictions about how our own world might change.
And that brings us to our last thought here. We've seen how code can create a surprisingly detailed copy of a life. We've got rules for aging and health, hunting and surviving. But what's the real relationship between this elegant, logical simulation and the wild, messy, unpredictable reality it's based on?
And that's the core of it, isn't it? Our digital eagle lives by a script. It follows functions and parameters with perfect, logical consistency. It has rules, but it doesn't have instinct. It has a health status, but it has no fear of death, no true, primal will to live.
So I'll leave you with this to chew on. By building this simplified, logical version of an eagle, we get to see just how incredibly complex and unpredictable the real thing truly is. If we can break a life down into code, what does that teach us about all the uncodable magic of life itself? That's it for this explainer.